In this video, we will discuss about intrinsic impedance of the electromagnetic wave. This intrinsic impedance is an important parameter of electromagnetic wave in a given medium. Intrinsic impedance represented by neta. Represented by neta. It is impedance of the electromagnetic wave. Basically, this one is depending upon the given medium. Based on the medium, this intrinsic impedance of electromagnetic wave is varied. Now let us see the definition of this intrinsic impedance. It is defined as a ratio of magnitude of electric field intensity to the magnetic field intensity. It is defined as a ratio of magnitudes of electric field intensity and magnetic field intensity. Now we will derive intrinsic impedance expression in terms of the medium parameters. We know that wave equation. What is wave equation? That is given by del square E equal to gamma square E in terms of electric field intensity, or in terms of magnetic field intensity it can be written as, just replace E with H, then you will get wave equation in terms of magnetic field intensity. This can be written like this, that is dou square E by dou Z square. Let us assume wave is traveling along Z direction. In that case, this becomes del becomes what? Dou by dou Z Az. Az indicates what? Direction of the wave. Az is unit vector of the wave. As wave is traveling along Z direction, Az indicates unit vector of the wave along Z direction. Dou square E by dou Z square is equal to gamma square into E. Leave this one, we will analyze in terms of E. What is the solution of this one? It is a second order differential equation. For this one we will get solution, that is E in terms of Z, that is E of Z equal to E naught plus e to the power minus gamma Z, E naught minus e to the power gamma Z. If wave is along Z direction, E is functions of Z. Of course, H is also functions of Z, because as wave is traveling along a particular direction, field parameters are varied with respect to that direction only, not other directions. Means in this case, not X, Y, because wave is traveling along a Z direction. Okay, so this is what solution of E. Suppose if you want to mention the direction, if E is along X direction, then Ax. If it is along Y direction, Ay. Let us assume E is along X direction like this, and magnetic field is along a Y direction. Okay, as wave is traveling along Z direction, electric field is along X, magnetic field is along Y, then wave is traveling along the Z direction like this. Let us assume like this. What I said, E is along electric field is along X direction, that is Ex Ax, magnetic field is along Y direction, that is Hy Ay, and wave is along Z direction. Okay, in order to derive the expression for neta, we need to use the Maxwell equation. That Maxwell equation is nothing but what? We are using this Maxwell equation from Faraday's law, or else Maxwell equation. We have, that is del cross E equal to minus dou V by dou T. We can write this one like this, that is minus mu into dou H by dou T, since B equal to what? Mu into H. And we can write in terms of the frequency domain, or else in time harmonic form, we can write this one, that is j omega mu H. What I replaced here, dou by dou T is replaced with j omega. That is dou by dou T in time domain, dou by dou t. In frequency domain, that is j omega, or in harmonic form, dou by dou t can be replaced with j omega. This is the expression of what? Del cross E. Del cross E. Okay, let us assume E is along x direction, H is along y direction, and wave is traveling along z direction. What I said, as wave is traveling along z direction, del can be taken as what? Dou by dou z, as it is del square, dou square by dou z square. Here we can write this one as what? That is dou by dou z. Since wave is along z direction, as it is along z direction, I am taking this one as what? Az. It is magnitude of del, and this one is direction of wave, since wave is traveling along a z direction. What about E? E is along a x direction, that is Ex. It is magnitude of E along x direction, Ax, minus j omega mu. What about H? H is along a y direction, that is Hy Ay. Let us take the here He, these are the vectors. We can take bar, E bar, H bar. Here H is taken as Hy Ay, E is taken as Ex Ax, del is taken as dou by dou z Az. Now let us simplify this one. Let us simplify this one. Here you have what? Az Ax, Az cross Ax, cross product gives what? Z and X are perpendicular to Y. Cross product gives the another vector that is perpendicular to both Z and X. Dou by dou Z of, I am writing this one, Az cross Ax, Az cross Ax is Ay, this one. Okay, and dou by dou z of what is Ex? Here Ex is this one. Here magnitude of E is E naught plus e to the power minus gamma z plus E naught minus e to the power gamma z. For simplicity, I am taking wave is along positive direction. That means, or else I have taken only forward wave. This is forward one and this one is backward one, or else reflected one. For simplicity, I am taking only forward wave. Okay, this one only, I am taking this forward wave only. We can write this one as what? Ex, that is E naught plus e to the power minus gamma z, minus Az cross Ax in equal to what? Into Ay, minus j omega mu into Hy Ay. Here direction along y direction Ay, here also Ay, both are gets cancelled. And simplify, write the expression. What is the expression you require? Magnitude of E and magnitude of H. Magnitude of E along x direction is Ex. Ex is what you have taken? E naught plus e to the power minus gamma z. And H is taken as what? Magnitude, that is Hy, that is Hy. Here you can see Ex magnitude, H magnitude, Hy. Now let us simplify that expression. Differentiation of this E naught plus e to the power minus gamma z with respect to z gives what? That is E naught plus e to the power minus gamma z. Differentiation of this one with respect to z, that is e to the power minus gamma z. Differentiation gives what? E to the power minus gamma z into minus gamma minus j omega mu into Hy. Then this minus cancel, and it is equal to what? Generally it is Ex. This one is equivalent to what? Ex. J omega mu into Hy into gamma here. Ex into gamma. This is equivalent to Ex. Here you have gamma. What you require? Ratio of E to H. Magnitude of E is Ex. Magnitude of H is Hy. Since we have taken E along x direction, H along y direction. Then we have what? That is j omega mu divided by gamma. Gamma is propagation constant. This gamma is given by, but where gamma is equivalent to under root j omega mu sigma plus j omega epsilon. Let us substitute that one. In this one, you will get j omega mu divided by under root j omega mu sigma plus j omega epsilon. Then this j omega mu can be written as what? Under root j omega mu whole square, or else under root j omega mu into j omega mu. This j omega mu, this j omega mu cancel. What is the remaining part you have? Under root j omega mu divided by sigma plus j omega epsilon. What is this one? Ex by hy. That is nothing but mod e by mod h, or else mod of e by h, that is equivalent to what? Neta. Neta is equivalent to j omega mu by sigma plus j omega epsilon. This is the expression of the intrinsic impedance. This intrinsic impedance depends on these parameters. Of course, given frequency omega, that is angular frequency, mu, that is permeability of the medium, sigma is conductivity of the medium, omega is given frequency, and epsilon is what? Permittivity of the medium. That means at a given frequency, intrinsic impedance of the EM wave in a particular medium depends upon the medium parameters mu, sigma and epsilon. These mu and sigma epsilon are known as the medium parameters. Now we can take the special cases of that intrinsic impedance. What is the intrinsic impedance expression? Just now we derived that as neta equal to under root j omega mu by sigma plus j omega epsilon. Case 1 for lossless medium. Case 1 for lossless medium. What is meant by lossless medium? For lossless medium, sigma equal to 0. For lossless medium, sigma equal to 0. As sigma equal to 0, neta equal to what? Neta equal to what? Sigma is 0. Then we will get what? J omega mu by j omega epsilon. Here j omega gets cancelled. It is equal to what? Under root mu by epsilon. So that is for lossless medium, neta equal to under root mu by epsilon. Here it is complex quantity, that is real plus imaginary form. Here it is purely real. That means for lossless medium, intrinsic impedance is purely real. Next, case 2 for free space. For free space, conductivity is 0, epsilon equal to epsilon naught, mu equal to mu naught. Therefore, we can write neta as what? Free space is an example for lossless medium, that is sigma equal to 0 for lossless medium. In this case, we can write neta as neta naught under root mu naught by epsilon naught. Let us substitute these values, that is 4 pi into 10 to the power minus 7 Henry per meter, that is the mu naught value, and epsilon naught value is what? 1 by 36 pi into 10 to the power minus 9, or else 8.854 into 10 to the power minus 12 farad per meter. So if you substitute these values, you will get what? That is, it is equivalent to 144 pi square into 10 square. If you simplify that one, you will get root of 144 is 12 into 5 square, sorry, 12 square, root 144 is 12 into 5 square is, that is 12 into this 5 square is 5, sorry, 144 5 square can be written as what? 12 5 whole square, that becomes 12 5 into 10, that equal to what? 125 ohms, or else it is equal to what? 377 ohms. Okay, in this video lecture we derived intrinsic impedance. What is intrinsic impedance? It is defined as the ratio of electric field intensity to the magnetic field intensity. Of course, we have to take the magnitudes. In order to derive this expression for intrinsic impedance, we need to use what? Wave equation. What is wave equation? Del square E equal to gamma square E. What is gamma? Gamma value is under root j omega mu into sigma plus j omega epsilon. This gamma is known as propagation constant. And we used one Maxwell equation. That Maxwell equation is nothing but what? Del cross E equal to minus dou V by dou t. That is in time domain. In frequency domain, that equal to what? Del cross E equal to minus j omega mu into h. We assumed wave is traveling along z direction, electric field is along x direction, and magnetic field is along y direction. And we have taken only forward wave case. For that, we got neta value as what? Neta equal to, that is E by H equal to under root j omega mu by sigma plus j omega epsilon. In case of the backward wave or reflected wave, we will get same expression, that is neta equal to, that is mod E by mod H. In the previous case we have taken what, that is E naught plus by H naught plus, that is forward case. For the reverse case, that is reverse wave, you will get E naught minus, here H naught minus, here you will get minus. This is the relationship between forward and reverse magnitudes of EM wave in terms of theta. Okay, this expression is equivalent to what? Under root j omega mu by sigma plus j omega epsilon. And after deriving this expression, we have taken special cases. One case is lossless medium. In that case, theta is under root mu by epsilon, that is real. And case 2 is what? That is for free space. Free space is an example for what? Lossless medium only. But epsilon is epsilon naught, mu is mu naught. In that case, we got intrinsic impedance is approximately equal to what? 377 ohms or else 125 ohms. We will meet in next video.